And we are live. Hello, hello, everyone.
Hey.
How are you, Mike?
Pretty good. How are you doing?
Yeah, I'm good. I'm good. All right. Shall we introduce ourselves?
Yeah, go for it.
All right. My name is J-Lo. I'm the product manager of Home Assistant.
And I'm Mike Hansen. I am the voice guy at Nabukasa and the creator of Raspy.
Cool. Nice. Before we start, we both work at Nabukasa full-time. Nabukasa is a company that was founded to make the development of Home Assistant sustainable. We provide a service called Home Assistant Cloud, which lets you connect your Home Assistant instance remotely. And when you subscribe to Home Assistant Cloud, we can use that money to employ more people to work on Home Assistant and make it better for you. And you will see that in this stream in particular, Home Assistant Cloud is one of the simplest way to experience the power of our voice assistant. You will see it mentioned many, many times. So,
and
all right.
It's the best way to support us.
Exactly, yes, yes. Right, before we start, why are we there? Is it? I thought Year of the Voice was over.
No, so the voice is continuing.
Okay.
They didn't fire me on midnight of December 31st.
That's nice.
I don't think there's a theme for this year, but voice is going to continue, kind of as not the main feature, but still in the background. We're going to have streams and releases as time goes on. And there's been lots of great work already that we'll get into. But yeah, we're here for a very particular purpose.
Yes. All right. Last year was Year of the Voice. Do you want to summarize quickly what we did last year?
Yeah, so I won't spend a whole lot of time here because we've got some cool tutorial stuff to show you, but I will go over real quick for people who may not be up to speed. Basically, the goal of the Year of Voice was to allow users to control Home Assistant in their language, and that's a big ask because Home Assistant supports 60 plus languages, and I'm also only one person, so we had a great year. We started off getting things to work with text. And we'll kind of go through the same progression here to show you all the things you can do. But basically, you could type text and make Home Assistant do things in different languages. We moved on to voice then. So you could talk to Home Assistant and it could talk back to you. The main, the easy button way of doing this is having Home Assistant Cloud. This uses Microsoft's Azure under the hood. It's very fast, very accurate, and tons of supported languages. But of course, Home Assistant is about choice, and so we also added local options. We have Whisper for speech to text, which came from OpenAI originally, and then Piper is our own in-house text-to-speech system that we built to work great on a Raspberry Pi 4. So all that stuff runs locally, and we also added some hardware options early on. We started using analog phones. Actually, you can use these through an adapter, so you could talk to your house through the phone, which is kind of cool. And then the Atom M5 Stack Atom Echo Smart Speaker Development Kit.
That's a nice name.
Yes. It's a little $13 tiny little remote. It's got a little microphone, little speaker in there. More for playing around and trying things out. Less useful as a replacement for a real smart speaker. But we went on to add support to Android. So if you have an Android watch, you could set Assist, which is the name of our voice assistant and Home Assistant, to you could basically hold down the button, speak your command. Same thing with the phone. If you have an Android phone, you can hold down the button and you could speak your command. And then later on, we ended up adding WakeWord support, which is a big desired feature where you could actually say, okay, Nabu, or something to wake up your device and start speaking. And that works through streaming. So any device can stream audio. Home Assistant does the WakeWord detection. There are some other options for local, though, that we'll go into.
Yeah.
And then lastly, we kind of rounded out the year with more hardware options. So Espressif has the ESP32 S3 Box 3.
Not that one.
Yeah, there's two different versions. So we want to make sure people realize there's the old.
You have the
S3 box.
You have the light one, right?
So this one, the blue one is the new one. You can see it looks far less. It's not 3D printed anymore. And this one, I think the casing was, at least it feels 3D printed. This one is now
have even a different one. You have the light one. That's the light one.
Yeah, that's the light. You got the full. The old one is discontinued. So ignore that. This one, I would say, if you're wanting to go kind of an easier all-in-one, just buy it and get going route, the S3 Box 3 is the way to go, and it's something that we're going to be supporting more throughout the year. So this would be a target, but we're going to have tutorials here for people who want to DIY it.
Yeah. Just one thing, like what Mike said about like forget that one if you want to buy one, because if you have one, it's the same internal. So like don't upgrade it just for the sake of upgrading it. It's the same.
Yeah, don't throw everything away just for the blue thing.
Yeah. Like
they do have these cool docks though.
Yeah.
Okay, and and the last thing, the picture there are these we're calling them Wyoming satellites. So Wyoming is the protocol that I developed that all of the voice services use to talk to each other, and you can run a satellite through a Raspberry Pi. So here I had a little Raspberry Pi 02W, and I'm going to be going through how to build one with a Pi 3 in this live stream. So that was the Year of Voice in a nutshell, big nutshell.
It was nice, right? It looks like a Apple keynote slide, you know, when they present a new phone with all of the boxes and everything we did.
One more thing. No.
One more thing, yes. We don't have one more thing, actually. What I like the most about what we did is that you will see in the stream, we will present a bit. I mean, if you know, you know. If you don't, we will present it like all the voice assistant is built component per component. We have many components for different purpose, like a WakeWord component, a text-to-speech component, etc. All of them can be customized easily, so you can run your own WakeWord, your own sentences, your own everything. Which means that when we are creating voice assistants, we are actually creating a lot of different ways to actually communicate with your home. And in this slide, I'm focusing mostly on the fact that it can look anything you want. This is mostly like a customization on the hardware side, but it goes much beyond that, because again, as I said, you can change your WakeWord, change the language that your voice assistant will speak, the sentence it will react to, the response it will speak, the action it will take, etc. So it's almost everything is customizable, and this is really great to see. And this is actually one of the triggers that made us think about doing a contest. You can see I specifically actually picked almost all of them are made by us, because everything that is on the community should be part of the contest, more or less. This is how I see it. So here you have like a HAL 9000, you have a Droid, you have a Walkie Talkie, you have like what's this name, like a Nabastak rabbit, you have like the box, etc. So yeah, I mean, we spent like 1 year building things, and we think that it's time now to celebrate what we did can enable with the community, because again, like everything is customizable. So if you have an idea, normally you should be able to build it, right? Maybe you are missing a few resources to do that, and this is why we are here. But like there is no chains in the customization part. Like everything it can be customized, which is pretty cool. So yes, we are starting a contest. I will explain you. So there will be two parts of this live stream. A small part about the specifics of the contest, what it is, when is it, how do you participate, and what are the prizes, because we have prizes. And then the second part will be mostly two tutorials on how to build voice assistants on the two main platforms that we support: Wyoming on a Raspberry Pi, ESPHome on an ESP32 board. So the contest, I see the French and the Nabastag community crazy on the comments. So first, the contest. When is it? It starts today, and it ends on the 10th of March. So 2 months, a 2 months contest. I'm going to explain to you what it is later. I just want to explain you when it is. So it is from today to the 10th of March, mostly like 2 months contest. 5 days later, the end of the contest, we will announce winners. They will gain prize. And a month later, mostly the 10th of April, we will have a closing ceremony. So another live stream where we will invite the winners to come and explain to us what they did, which is cool. What is it? So it's a contest that is centered around voice overall. We have some categories of how you can enter the contest. However, I would say that the categories are more like a guideline, meaning that if you have an idea that fits maybe 2 categories or doesn't really fit a category, I would say please participate. That's the goal. The goal is really like to foster this collaboration around our voice assistant. These categories are, again, just a guideline. All right, so the first category is the most creative satellite ideas. So this is really about hardware stuff. This is about building a Walkie Talkie or like a Pitayas droid, things like this. And I really think that we have all of the ingredients to create something like this, because it's so like it can be so small that you can retrofit it a bit everywhere. This is a big Talkie, but you can put voice assistant in things that are much smaller than that. We have custom voices, custom WakeWord, custom sentences, custom everything. So you can really create an object that that looks amazing. I would say one of the main example is Pitaya's droid, which I should have actually prepared a video. Give me one sec.
Yeah, you should show that.
Yes, I should show that. I mean, this thing, I mean, is amazing for many reasons, but it's amazing because it's everything at once. It's like the look, the feel, and the way it talks. It's like everything, which is great. So this is by Paul. Let me just bump a bit the...
Hello, I will show you my new voice assistant. It's a droid from the Star Wars and Mandalorian universe. It's a R5 droid. It's 3D printed. It runs ESPHome on a ESP32. It has microphone, speaker, and servo motors. And I will show you a small demo. He will respond to his name, which is R5, but I will call him in French because the WakeWord is configured in French. R5, turn on living room lights. R5, turn off living room lights.
Very cool.
So yeah, I mean, this is just like the fact that we can do all of this, and we have like even the text-to-speech engine that talks like a robot at the end.
Very cool, very cool. So that would be an example of a very creative satellite.
Yes.
Let's see. Next category is best starting guides. So this is for like the most kind of easy to follow and comprehensive and usable guide to produce something that's usable at the end. So this could be, you know, a long form blog post kind of thing. Video would be best, I think. And this would be something to basically take a novice from knowing nothing to having something usable at the end. Yeah. And I think we have one example that we found.
We have one example that we really like a lot with Frank, which is the 2 or the 3 videos of future-proof homes that goes into very much detail about the Wyoming Satellite, and also building like a whole GPT-powered home assistant, voice assistant that runs locally. I mean, the videos are just very good, very nicely done. It's super easy to follow. I mean, yeah.
So things like that for best starting guides.
Yeah. The third category, which is something we don't have examples, and you will explain. You will understand why. It's best event organized, best group effort. I would say. It's always fun. It's fun to create voice assistants. I think it's even funnier when you do it with actual other human beings in a hackerspace, where you explain a bit, where you share what we do. And so we want to also celebrate this, even if it's going to be a bit more difficult to judge.
All right, and then the final category is best voice experiences. So, you know, this is something different than just looking cool and sounding cool and following a theme or something like that. This is more like basically taking what's there and producing something that's completely useful, like replacing an Alexa basically, or Google Home or something like that. So what you want to actually have a smart speaker, or could just be just microphone, but something to where you've tuned it so heavily that it provides just an excellent voice experience all around for, you know, a typical use case, something like that. Very heavily integrated into your home, something along those lines.
Yeah, it's like we have like all of these components, and you can use the power of all the scripting and automating on Home Assistant. which means that if you have an idea, usually you can do many things. One example that I gave there, which is coming from me, again, because I don't want to bias the thing and I'm not going to participate anyway, it was like the idea of being able to play music in any speaker of your home powered by ChatGPT for the search part. So being able to say, like, I want to play the Pink Floyd album with the rainbow on the cover, and then outputting basically just the correct album to any speaker on your home. And I go into detail, but at the end of the day, which is what is very cool with Home Assistant, is that it's a blueprint, right? So you click on one button at the end and you're done, right? You have it. And so that's about it. I missed my screen. Give me 1 sec. Slides. No. Share screen. Right. So this was the category of the contest. So we have the time, and we have the categories. How to participate? This is pretty simple. The entry of the contest itself can take any form. As we said, it can be a blog post, it can be a website, it can be a video, it can be anything you want. The only thing that you need to do to participate is to create a post on one of our category on the community forum. It's a new category called Voice Assistant Contest. That's pretty simple. If it's not visible now, it will be visible at the end of the stream, or let's say tomorrow. But the category is there. That's how you enter the contest. Prizes, because we have prizes, of course. Mm-hmm. For each category, even if, so for each category, we will pick a winner that will get Home Assistant Green, which is a very nice hub to run Home Assistant for new joiners. Basically, it's a plug-and-play appliances. You plug it and you have Home Assistant, the full experience, the Home Assistant OS. The winner will also get a Sky Connect, which is a radio that can be used to connect Zigbee devices or Thread devices. Connecting Thread devices can help you to connect like the new standard called Matter devices, even if Matter and Thread are not the same thing. Go watch the stream of last week.
And I guess that's how you can anger a Matter developer by saying, "Isn't Thread and Matter the same thing?" Or
it is it's the same thing. So this is a Matter radio, Marcel. No.
Oh no.
And we will also give the Sky Connect to runner-ups. So every other entry that we deemed were cool. On top of that, we already said it, but the winner will also get an invitation to a live stream on the 10th of April to talk about what he did, which is pretty cool.
Yeah.
And then
the community. So in addition to us being judges, the community also gets to select one prize winner. And so this will be one person who gets the Home Assistant Green and the Sky Connect, and also a place on the live stream. And the mechanism for voting here is going to be within the forums. So you go there to the particular Voice Assistant contest category, and you can vote there on the topic that relates to that particular project. And whoever gets the top vote there, I suppose, will be the community winner.
Exactly. Yes. All right. So that was the contest in itself. By the way, if you go to the forum category, if it's not live, it will be live again. We have a FAQ with a bit more technical details about the forum, the contest, but more or less that's the contest. 2 months contest. On the 10th of March, we stopped the submission. On the 15th of March, we announced the winner. On the 10th of April, a live stream with the winners of each category and the winner of the community that will explain what they did. And now we are going to make let's say a primer on everything that we did in the least amount of time.
We'll try.
We'll try, yes. So it's going to be more or less 3 main parts. It's pretty easy. We are going to do everything we can on Home Assistant without talking about devices, right? Because Voice Assistant is a two-device job, right? You have the device on one end and you have Home Assistant on the other end. So we are going to configure Home Assistant as much as we can. We are going to show you all of the components, everything that you can do on Home Assistant. As soon as we are a bit blocked, Mike will jump in, will build a voice assistant using the Wyoming service, so the Wyoming Satellite. And then I will build a ESPHome voice assistant. So at the end of the stream, you will have a very, I hope, a good knowledge on everything that you need to do on Home Assistant to use voice in the best way. And you will have 2 nice tutorials. Not the best, actually. The best will be yours for the best starting guide, but nice guides on Wyoming and ESPHome, which are the 2 platforms that you can use for voice assistant. All right, so voice features on Home Assistant, most important voice features on Home Assistant. Otherwise, we would be there for like a year. Before we start, we said it, our voice assistants are per component. I want to show you the components because we are going to mention them and mention them and mention them. And if you don't know what they are, you may be a bit lost. So our voice assistants are composed of 4 main components, which compose what we call a pipeline. So in order, you trigger a device by saying a wake word. So you have a wake word engine that basically listens to this wake word and trigger the whole thing. Then you speak. There is a speech-to-text component that is going to transform the speech into text, hence its name. You have a conversation agent that is going to understand this text, do something or not, depending if you want to touch your devices or not, and reply with text. So turn off the lights turn off, and the answer will be lights turn off. And then you have a text-to-speech component that takes this text and reply it to speech. What we are going to do I'm going to start actually by this side. I'm going to start by the right side. So I'm going to start by showing the conversation agent. So we will do text to text, showing you a bit what we did there, which is mainly chapter 1. Then we'll go speech to speech. We will add the speech to text and text to speech, which will mainly be chapter 2. And then we will add wake word to the whole thing. So you will see all of the components. Then we will put that into action with the devices.
Yeah, I do want to say, so the arrows that are between the different components, not to the person. The person arrows are going to be the hardware, right? The microphone, the speaker. But the arrows between components, that's Wyoming.
Yes, that's Wyoming.
This is the little protocol that says here's the audio, here's the particular action I want you to take, that sort of stuff. And what's cool is that arrow doesn't have to be on the same machine. So we'll show it can go to a different machine that's more powerful. It can go to whatever you want. It's just all it needs is just an address and a port.
Yeah, exactly. Yeah. We will show you many things. Things will run on Home Assistant, things will run outside of Home Assistant, things will run on the device, not on the device. We're going to show you a bit everything. But the Wyoming protocol is making all of this very customizable. Okay, so let's go directly on Home Assistant. Before I start the setup, I started from the simplest setup possible, meaning that this is a fresh installation of Home Assistant. I just have my lights. That's the only thing I integrated, just because I want to show you feedback. One of the main lights will be like the big bunny that you see behind me, which is this one, which is going to be used to show what I'm going to do. There is nothing else. I just have a few add-ons that I installed that I will share with you when I'm sharing it, when I'm presenting them. But this is a very fresh install. Sorry, one thing. I'm connected to Home Assistant Cloud because it's needed to make most of the voice. Okay, so let's start by just, again, text to speech, text to text, our conversation agent. There is a button there called Assist, which is the name of our voice assistant. And you can speak to your home in a very natural way. So for example, I have a light called Miffy, which is a very weird name. It's on purpose that it's a weird name. Also, my area names are in French, which is also on purpose because I want to show you how to change that. And I can say turn on Miffy. And you will see that the bunny behind me is turning on. I can set Miffy to red, and it's going to be red. And I can turn off Miffy. So this is like, turn off Miffy. So this is like a very basic, you can talk to your home in a natural way.
Just want to come and say, so the text commands that you're able to type here, this is something that the community has contributed. We have a repository on the Home Assistant GitHub where we have leaders for each language. and they take in suggestions for sentences, and they code them up in this special templating language. You could see, like, when he said turn of the MIFI instead of off, so it's fairly strict in how it operates. So this is something, if you find a language, if you find a sentence that you think should be supported, you can come here and contact one of the language leaders, post an issue. If you see a language that is not supported and you would like to help contribute, please get in contact with us. You can email us at voice@nabukasa.com, or you can contact us on GitHub here. But this is where this is coming from. This is really a community effort for the contributions here.
You can see all of the progress per language, and you can see all of the languages that we support. But the point is that the language leaders are trying to make this completely transparent, meaning that you should be able to talk to your home in a very natural way. I will show you actually how to extend that, right? We are right at the beginning, but like what comes out of the box should be natural. Okay, so something that I want to point out that is not really related to voice, but actually it is. And it is maybe, I'm not going to say a hidden gem, but not everybody knows that. And it's the fact that a device, an entity has a name, and an area also has a name. And this is why everything is named weirdly, because, well, I'm French, so everything is in French, etc. But right now I'm doing a stream in English. There is something called aliases in Home Assistant. If you go to any entity and you click on the cogwheel and you click on voice assistants, you can add aliases, which are different names that you will be able to query by voice. So instead of saying like turn off MIFI, which is a bit weird, I can just say turn off the bunny, and it's going to work. So I can do that for example, for a device, and I can do that also per area. Actually, did I? Yes, okay. And I can do that also per area. So if I go to settings, area, and bureau, which means office, I can click on this overflow menu, area settings, and I can add an alias, for example, office, or I can add workshop. Save. So this basically is a way to make you say like much simpler sentences. Now I can say like turn on the bunny, and it's going to turn on the bunny. Or I can say turn off the lights in the office. Turn off the lights in the office. It's going to turn off all the lights in the office. And now I'm going to turn them on. So aliases, yes, like it's a pretty simple, basic thing, but it really helps you a lot in the voice assistant part. Actually, I forgot to say something, but you can also, if you don't want this MIFI to be targeted by voice, you can also just go to voice assistant and unexpose it.
Yep.
And if you do that now, if you say like turn off MIFI or turn off the bunny, then Assist will tell you, I don't know what that is. Like,
we'll show it, see what happens.
Yeah, I can.
Unexpose it, let's see what happens.
Sorry, up. Turn off.
So,
security feature, yeah, in a way, security feature, yes, and also just a way to make sure that you don't target things that you don't want to target, for example, scripts, etc. Yeah. All right, so that was really like just text to text. We are going to add voice into voice, which is more interesting, I would say. No, actually, no, sorry. Before that, something that we can also test just voice to voice. If you want to, if you have a specific idea for a specific sentence that is not on the intent repository that Mike was talking about, for example, this light can do random color. There is an effect that can do random color. I can just do that, and now it does random color. You will see that it changes color. It goes yellow and green, etc. And of course, we don't have an intent to say like turn the light in a random color, because it's pretty specific to me. There is a way to do that, which is super easy, which is tapping into our automation system. If you go into automation, I already have them. I'm just going to show you them because they are very simple. You can create an automation that is triggered on a specific sentence. It's on the add trigger. You just search for sentence, and you just put any sentence that you want to trigger. So for example, here I put the trigger. Sorry, I just need to remove that. Set the bunny to random. And I can even show you a bit the beginning of the, like that's the syntax that we use for intent. So for example, here I said that the would be optional. So I can say set bunny to random. And then I'm just turning on the bunny light with the correct effect. Save. And then I have another one, which is set back bunny, for example, to normal. And it's just turning on the bunny without effects. Save. And now I just extended the set of sentences that Home Assistant understands just for me. So I can say set the bunny to random. And it's going to be now cycling through the colors randomly. And I can say set back the bunny to normal. And it's just going to go back to normal.
And so these sentences they take priority over the other ones, the built-in ones. So you can, if you also want to override your the ones that exist, you can do that. There is another mechanism for adding custom sentences where you can actually add YAML and all that. That's more complicated, and we won't go into that here. There is a tutorial, though, that talks about it. But that's where you could get access to basically the full power of the template.
Yeah. I saw one question, which was the fact that, yes, the answers of this is done. I think I can say it without a problem. We are working on it right now. So we should be able to set the response soon, like very soon. Like we are actually working on that now.
Yeah.
All right. So now let's add actually voice to voice, because for now we just did text. Again, so in your settings, you have something called voice assistant. You should have some default voice assistant that don't have this name. You should have one called Home Assistant Cloud if you're using cloud, etc. I just remove everything, try to remove everything because you need one. And we are going to start by scratch because I want to show you what it is. This is how you configure the famous components that I was talking about before. So all of them, right? So you set a name. So let's say Home Assistant Cloud, and we'll try to put names that are making sense because you will see that we'll have a lot of them at the end. You can set a language for all of that. And then you have the conversation agent, which is only Home Assistant, and we'll only say Home Assistant for that tutorial, but just know that we have others, we have that are merging ChatGPT and Home Assistant, etc. We have crazy things on the community, which should be part of like the voice assistant experience, the best voice experience.
Yeah.
Speech to text components, Home Assistant Cloud. Let's ignore this one for now. Okay, so this is the components that is using our cloud services privately. Not locally, of course, but privately. We don't even know what you are talking because it's directly connection between you and the cloud of Azure for speech to text. And this one is for text to speech, same thing. So American English, you have different voice. You can even try the voices.
Hello, JL. How can I assist?
Why not? And then you have the WakeWord, which I'm not going to go into detail right now. So now this is what we are calling a pipeline. Up Home Assistant Cloud. And we can test it. There is many ways of testing it, but without any device, the best is just to go back to Assist, to take the correct pipeline, and just to click on that button. Turn off the bunny.
Turned off the light.
That was pretty stupid because it's already turned off. Set the bunny to blue.
Color set.
Set the bunny to green.
Color set.
Set the bunny to random.
Done.
Yeah, so that was the custom one. So everything works, of course, like this is everything componentized. Turn off the bunny.
Turned off the light.
So this is like the simplest way, I would say. Home Assistant Cloud, very fast.
And just a note, if you open up the assist dialog and your microphone is crossed out, you aren't accessing Home Assistant locally or over HTTPS. Unfortunately this is a browser security thing where if you're not securely connected, it's not going to send microphone data. So if you see that's why. But we are able to use it through other devices.
Yeah. Yeah, exactly. Like this is just to test. Like usually you don't really use that. You go to a device, and of course for a device you don't need to have like a cloud connection or whatever. But yeah, for this is a browser security.
And for an Android phone, it will work.
Yes, exactly. Yeah. All right. So this was one option, which was like this is the easiest. We want to show you a bit everything that exists. Now we are going to do like the local option, which is using different components for text to speech and speech to text. This one we're technically on the cloud. Let's say it like this. We are going to use Piper and Whisper for this, which are add-ons. So you go to add-on and you download Whisper for speech to text, Piper for text to speech. Whisper is a component that is part of OpenAI, and Piper is in-house. It's built by Mike.
And while Whisper is part of OpenAI, it is running locally.
Yeah. Okay, so we are going to demo that. I just want to tell you that now everything is a trade-off, more or less, because our Home Assistant cloud is extremely fast because it runs on cloud in a private way, meaning that yes, it is cloud-based, but we don't know anything about what you are saying, and we don't funnel your data, which is already pretty good. Local means that it's going to take resources in your home to be able to do these operations, which are actually pretty complex. Piper, so the text-to-speech is fine. On a Raspberry Pi, here I'm on a green. This is honestly like usable. Whisper requires a bit more power than a Raspberry Pi. I will show you actually like a green setup with something next to something a bit more powerful, and you will see that it's everything is a trade-off, more or less. And then on Whisper, on the speech to text part, you can change models and parameters. And basically, if you gain in speed, you lose in accuracy. If you want to gain in accuracy, you lose in speed. So it's a game of what you prefer, accuracy or speed. So you download the add-on, you run them. If you do that, the first thing you will see, which is that if you go to device and services, you will see things popping up on the discovery protocol. Wyoming, everything is on the Wyoming protocol. Piper and Whisper. So I'm going to just configure both. Piper, done. Whisper, done. I'm just going to name them differently for the sake of simplicity, because I already have some of them that are running on another server, which is a bit more powerful. So this one is Whisper. I'm just going to say that it's Whisper green because it's running on a green. And I'm also going to name the entity Whisper green so that we know where it's coming from. And this one, I'm just going to name it Piper green because it's running on a green, and the entity also. So that you will see why I have things running on the NUC afterwards. I want to explain you that. Okay, so now if we go to voice assistant, we can create another voice assistant. You can have as many voice assistants as you want. I'm going to call it local. Also English, conversation engine, home assistant, speech to text. Now I'm going to use the Whisper that we just configured. And for speech to text, the Piper that we just configured. You can change voices. You can try the voice.
Hello, JL. How can I assist?
That is not as fast as this. This is because it's cached. We are caching all of the answers. This is why the answers are usually pretty generic. We said like turn on light. We don't say turn on the bunny because we want to be able to cache the answer for every other lights that you want to turn off. But if you want to see the speed, we can say hello, dude.
Hello, dude. How can I assist?
It's actually not that slow. Like Piper is actually fine. And this is working on a green. It's going to be Whisper that will be a bit the bottleneck there.
I will say for people who run Piper the very first time, it doesn't come with any voices downloaded. So that however long it takes you to pull it from Hugging Face.
So create. Now we can test this one. So up, local. Turn on the bunny.
Turned on the light.
So yeah, it's a bit slower. Everything is local now, right?
So
turn off the bunny.
Sorry, I couldn't understand that.
This is what I was saying with the trade-off between accuracy and speed. I think we are running one of the lowest model on the green.
Yeah, I think on the green there you're running the tiny quantized, so it's tiny and compressed, and it's running with the least amount of memory possible.
Yeah.
But I mean, for people who have been in the voice space for a while, the fact that this is running on such tiny hardware like the green is incredible at all. Someone in the comments mentioned there is they mentioned something called VOSC. I don't want to get into it in depth, but I want to say that there are more speech-to-text local add-ons that I'm working on that are coming. They will have more trade-offs, though, just like you see here with accuracy versus speed. So when you go local, you're going to expect trade-offs.
Yeah. Just to show a bit the difference, I have also set up Whisper and Piper that are running on a more powerful machine. I don't have like a beast, but it's a nuke. It's an i7 nuke. I want to show you a bit what it may look for something that is usable locally. So I'm just going to create another pipeline called local fast. And it's going to be fully local. Speech to text will be the Whisper on the NUC this time, and the text to speech will be the Piper on the NUC also, US, and I will just use the same voice, create. And you will see that this one is a bit more usable, I would say. Turn on the bunny.
Turned on the light.
Set the bunny to blue.
Color set.
Turn off the bunny.
Turned off the light.
So that was fully local, but yes, it's always a trade-off. Yes, it's local, but I have another server running at home for that. So everything is kind of a trade-off.
And yeah, Jayla's not going to go into exactly how to configure these things running remotely, but the short answer is
Docker.
they're running as Docker images with an IP address and a port. And when you go to here, you can probably show it as devices and services. When you click add integration, you can add a Wyoming integration and point it. Yeah, go ahead and click Wyoming protocol. So here you pointed at the host of IP address of your server and the port that you configured when you ran the Docker image or the other add-on. That's all.
Yeah, that's it. Yeah. All right, so we were there. Let's add WakeWord. WakeWord is it's the weird one because usually in all of the things that you have at home, like Alexa, sorry, I should not have said that word, my bad. Like Apple HomePod or like a Nest Mini or things like this, WakeWord is on the device. And here what I'm going to do is I'm going to use WakeWord on the server, which is Home Assistant. But that would allow me then afterwards to use very simple boards like this to do a voice assistant. And Mike will go into the route of local WakeWord. So the first one, that's there is multiple options, but I will give you like the base and then we will extend it. The base is called openWakeWord, which is also an add-on. And this one actually runs pretty well on a Raspberry Pi. openWakeWord. You do the same thing, you install it, you start it, and then if you go to devices, you will have openWakeWord, which we can configure.
And openWakeWord, we didn't develop that. That was developed by an external contributor. His name's David.
Yeah.
His last name, I hope we're pronouncing it right, Skripka. Awesome guy, awesome project.
Yeah.
And go check it out if you haven't.
So now we are going to configure our voice assistants for WakeWord. So the Home Assistant Cloud, let's go to this one. On the WakeWord part, we now have a, forget that one, I will explain you afterwards. We have an openWakeWord entity. And it comes by default with a few WakeWord. This one, Jarvis, Mycroft, Raspi, and OKNabu, which I will use OKNabu for now. I'm just going to rename the pipeline because we are going to have a lot of them, and I want to name them as the WakeWord because it's going to be messy otherwise. So this one is OKNabu with Home Assistant Cloud. And let's do also local fast, for example. Let's do OKNabu. OKNabu. Right. Here you the WakeWord is really done to be tested with a device. I will show you one way to test WakeWord without a device, but you will see that it's a bit hacky, I would say. But if you only have this and you want to work on the context, sorry, and you want to test WakeWord, you can still test WakeWord there, but it's a bit hacky anyway. So I will show you. You go to the pipeline. So for example, OKNabu, Home Assistant Cloud. You click on the overflow menu, debug. You click on that button, and then you can run a audio pipeline with WakeWord detection. So this is going to be all the steps. It's going to ask me all the things, and you can test your WakeWord. For example, Okay, Nabu. Turn off the bunny. No, it's already turned off. That's great.
Turned off the light.
Okay, Nabu. Okay, Nabu. Set the bunny to blue.
Color set.
So that was like from WakeWord. So that was the whole pipeline locally, and you can do it on a browser. It's just that you need to basically go into the debug pipeline. And just for fun, here is a full local pipeline. Okay, Nabu. Okay, Nabu. Turn off the bunny.
Sorry,
Turned off
I
the
couldn't
light.
understand that.
Okay, small bug. Sorry about that. I will just refresh the page. And that's it, right? So this is more or less what comes out of the box with openWakeWord, which is these 5, 1, 2, 3, 4, 5, these 5 wake words. There is 2 ways. I mean, there is a lot of ways, but there is 2 ways to have more wake word. One is to use a different wake word engine, and the other one is to add wake words to openWakeWord. I will show you both quickly. There is one thing that I want to say. I don't know if you saw, but I'm struggling a bit to trigger OK Nabu. Speaking on a different language, I mean, even if I have an accent and everybody knows that I'm French, it's okay. The wake word is actually pretty complex for me to trigger. And I think it's because, like, I don't know why actually, Mike, but it's very complex for me to trigger.
I mean, it was trained on an English model or English samples entirely. This is going to get better though. So I already have base models trained for German, French, and Dutch, and we're going to get these incorporated into the notebook that Jim was going to show you. They're not there yet, but let's show that.
Yeah. So the first way to add more wake word, which is very good for people that are either French, German, I think Spanish, Italian, is to use a different wake word engine called Porcupine. Porcupine is an add-on that you find technically not on the regular add-on store. If you're starting, you need to click on that overflow menu and you need to add a repository, which is the Raspi repository. And if you do that, you will have an add-on called Porcupine. I discovered a few minutes ago that actually the Home Assistant Green is not compatible with Porcupine. We have a bug.
I want to say for that, it's actually to me, it's a important thing to bring up about open source versus closed source. So Porcupine is closed source. There are new versions of it and whatnot that require cloud services that I'm not going to go into. But so it's basically a statically compiled library something is incompatible currently with the green, and we have no mechanism to fix it directly. So this is different than something like openWakeWord, where not only do we have a good relationship with the developer, but it's fully open source. Yeah.
So I'm still going to show you Porcupine, just that it's not going to run on that green, it's going to run on something else on the server, but it's still there. So it should be the same thing. You run the add-on, it's discovered by the Wyoming protocol, and I already have it, but it's just that it's running somewhere else. Porcupine comes with a lot of add-ons, a lot of wake words that are per language. And again, like as Mike said, it's cool, but it's closed source. We cannot change anything there. That's the one I use at home because it's a French wake word that works very well. So let's do Home Assistant Cloud in English. I can actually do the whole pipeline in English, just the wake word in French. Text-to-speech Home Assistant Cloud in English. And then wake word Porcupine. And I'm going to use a wake word that is Raspberry, but in French, Framboise. And then I can test it also. Debug, click, run audio pipeline with wake word. Framboise, turn on the bunny.
Turned on the light.
Framboise, turn off the bunny.
Turned off the light.
If you are French, Italian, German, and Spanish, I think Porcupine comes with quite a lot of different wake words that are working pretty well for you. I'm just scrolling the list slowly just to show you what is coming with. And I think from what I understand, Mike, this list is set in stone. It's not going to move. It's closed source. This is what we have.
Yeah, there is another add-on next to Porcupine you'll find called Snowboy that is also closed source and a bit older, but it does have the capability for you to train your own wake word with a couple samples. However, it will be a specific wake word just for you, so it might not work for other people in your house.
Yeah. The second way is actually to create your own WakeWord on openWakeWord, because it's fully open source. You can create your own WakeWord. We have a tutorial online. You can go to Home Assistant, Documentation, Voice, and create your own WakeWord. And you can follow the tutorial. It is based on a notebook, collab notebook environment. Mike, you want to talk a bit about it? Because
yeah, so this is something built by David. Again, we really appreciate this. So it runs on Google Colab. If you have a Google account, Google gives you so many free minutes of compute. And so this takes around an hour to run and should fit within the free window that you get. You can pay more for more time, of course. Or if you have a local GPU, you can get into that. It's a whole process, though. But that's how this is working.
The cool thing, so this is basically like a three-step process, which you have to do one thing. You enter a WakeWord that you want, like, I don't know, OK, Al, and then you just press play on step 1, press play on step 2, press play on step 3, and that's it. The thing is, like, it's like 1 hour more or less. Yeah.
And importantly, the hour or so it takes here, this is training the WakeWord up to a certain level. This is not the same level that the built-in ones have. Those were trained much more extensively. So OK, Nabu, Hey Jarvis, and so on were trained much more extensively, and you'll see a performance difference.
Yeah, of course. Yeah, I will show you that here. The cool thing is that at the end you basically have a file. It's just a small file, and so someone, which is just someone from the community, made a whole repository of WakeWord that have been trained for you, so you don't have to do it.
Yep. So thank you, Florian.
Yes. Thank you. If you go to English, you can see like all of the WakeWords that have been trained. And this is pretty cool because it is actually you don't need to do it, right?
And you can see some of these are not safe for work, just by the way. But this is a community project.
So you can see like it's even more hit or miss for me because I'm not English speaker, but we will try a few of them. I will try first OK Frank. I think I will just try one, which is OK Frank or A Frank. So it's always the same thing. You go to a folder, you have like the WakeWord that the model reacts, which is in this case 2 of them, A Frank or OK Frank, and there is a small file that you download. And then once you download it, you put it somewhere. You go to the file editor add-on if you have it. If you don't, you can use also Samba Share, etc. And you put it on Share. You create a folder called openWakeWord. Oh, sorry.
And this is all in a custom WakeWord tutorial that we'll link.
Exactly. Yeah. openWakeWord. And then here you just dump the file that you downloaded. So I will dump OK Frank or A Frank. It's a TF Lite file, and that's it. And automatically, without reloading anything, if you go to your setting, voice assistant, you can create another one, which I will call Frank. Let's say that Frank is local fast. We'll have like a bit of variety afterwards. Speech to text, whisper, nuke, text to speech, piper, nuke. And then WakeWord, openWakeWord, and you can see directly the WakeWord is there without reloading anything. Create. And again, because maybe I'm not English speaker, paired with the fact that it has been trained with less than OK Nabu, it is actually pretty complex to trigger, but I can try. OK Frank. OK Frank. OK Frank. Turn on the bunny.
Turned on the light.
Yeah.
So hopefully in the future there will be an extra drop down in that notebook that says pick your language, and it should get much better there for non-English speakers.
Yeah. And I think that's mostly it for this part, meaning that you saw, let me just come back to the recap slide. You saw how to talk to your house in a written format. You saw how to set up aliases on entities, areas. You saw the pipeline with like the speech to text, the text to speech, the WakeWord, etc. You saw the collab notebook to create custom WakeWord. You saw how to extend the sentences of Home Assistant with automation based on sentence trigger. And then you saw openWakeWord and Porcupine for the add-on for the WakeWord, OpenAI Whisper for the speech to text local, and Piper for the text to speech local. So that's like everything we can do without going into the device world. Now we are going to go into the device world. There is 2 main tutorials that we want to do, one on Wyoming and one on ESPHome. So I'm going to leave the floor to actually Mike.
Okay. So if you could show my other camera,
yes.
please.
Actually, I can even show it big. Give me a sec. Took.
All right. Man, that focus isn't great. Oh, well. So I'll talk a little bit. This is going to be a little mini tutorial. There are more extensive ones online that I'll link to on Wyoming satellites. So these are satellites mostly meant to run on a Raspberry Pi. And I will show off here. This is a Raspberry Pi 3, just very basic SD card. And I have, to demonstrate kind of bare bones components here, I've got, this is an old PS3i camera. They actually are fairly decent microphones, at least they were for the price back when they were around $6. Nowadays, I think it's not so worth it, but I wanted to demonstrate kind of a poor audio quality device first. And then I have this cheap little USB speaker that I plugged in. So those are the only things I've got hooked up. And what I've done is I'm starting with a Raspberry Pi OS Lite. So this is without the graphical interface. There's really no need for one unless you're doing some kind of dashboard project. So this would be if you got a Pi 3 sitting in a drawer and you got a USB mic and speaker, it could be a combo, speakerphone kind of thing, although those don't work as well far away sometimes. But this is how you could get started with a Wyoming Satellite. So let's jump over. I have a terminal, and this assumes that you have enough knowledge to basically administrate a Pi, right? So if you know how to flash a Pi and SSH into it, you could get started with this. And again, I'm going to run through things quickly. I've already installed some things, so we don't have to sit here and wait. But the full tutorial is in the Wyoming Satellite repository that we can link. So I've cloned the Wyoming Satellite project already, and I'm going to demonstrate the fun little installer. So people from the 80s, I think you'll be excited to see this kind of interface.
Nice. A UI, a GUI, nice.
Yes, a TUI, I guess, a text user interface. So this is there's the tutorial that we talked about a little bit earlier from Future Smart Home goes into like all the command line stuff for this. This installer has come after that, and I think for a lot of people this might be a nice way to get started, but you'll want to probably customize this further. All right, so to get started in the satellite section here, you can give your satellite a unique name, and you can select the satellite type. There are 3 types I'm going to go through. We're going to start with one that's just always streaming audio to Home Assistant. Home Assistant is going to be responsible for everything in the satellite type. So this would be great too if you have a very low-powered device that you can't even run local WakeWord detection. All right, so with that, I'm going to jump over to the microphone section, and I have an auto detect functionality here. So if I run that, testing 1 2 3 1 2 3 4 5, testing. Okay, so it auto detected the correct device. It could also have selected it from a list. And now, very importantly for this low quality microphone is the audio settings. So this uses a library called WebRTC to do noise suppression, and I have auto gain functionality. I'm not going to go into the details of why I'm picking these particular settings, but those are in the tutorial. So I'm telling it, it's going to run audio cleanup locally. That's basically what it's doing. All right, next I'm going to hop over to the speakers, and I'm going to test the speakers on the device. So here's my first device. I didn't hear anything, so I'm going to go to the next one. Okay, I don't know if anybody can hear that.
I can. Oh yeah, I can hear you. Yeah.
Okay, we can hear it. All right, so this is the correct speaker. You can also disable. I can turn the speaker up. And for demoing, I'm going to show I got feedback sounds that occur when you wake up the device and then when the voice commands finish processing. All right, so with that, skip WakeWord for now. We'll talk about that in a moment. I'm going to go ahead and apply the settings. So what this is doing right now is it's generating systemd services. So this is setting it up to boot when the Pi boots. And in fact, everything inside here is happening inside a local directory, and it's generating some nice services for me, service files. So this is where if you wanted to really customize things, you could edit these files and basically pick it up from there. And let's see, I'm going to actually look. Okay, so the satellite is running, and let's see, over on my Home Assistant, I'm going to share my tab here. So I'm going to share, just so you can see, I'm only going to show this part one time. Okay, so over here, if we go to devices, you can see it popped up auto-discovered inside Home Assistant. So I'm going to go ahead and configure that. And importantly, you want to give it an area too. So what's nice is we have this thing called context awareness now. So if you have a satellite device in a particular area and you say turn off the lights, it will turn off the lights in that area. It's aware of where it is. Okay, now, all right, I'm going to jump back to the terminal and leave it there. Okay, so on my Home Assistant side, I have a voice pipeline already set up, just like JLo. And so I should be able to, you can see now it's saying streaming audio. So it's actually connected to the server and just streaming it all there. It's the bandwidth isn't that much though, so it's not too bad. So now I should be able to say, okay, Nabu, turn on color light. All right, you see the light behind me turned on. Okay, Nabu. Okay, Nabu. Oh, I have.
Ah,
All right.
Finally.
I finally had a demo break. Okay, Nabu. Set color light to red. Okay. So we can see that going, and you can see that a lot of this is still in beta. Okay, so let's. I'm going to hop real quick through this. I'm not going to go into a ton of detail, but basically, if I were to go change the satellite type to voice activity detection, this would only stream audio when you're talking, rather than streaming it all the time. And it'll do the voice activity detection locally, obviously.
But still the wake word on the Home Assistant side.
Yeah, still the wake word on the Home Assistant. What I'm going to do is skip ahead and do local wake word detection because I'm running a Pi 3, and that's plenty powerful to run openWakeWord. You should, like a Raspberry Pi 02W could also do this. But I think probably a lot of people have a Pi 3 sitting in a drawer somewhere. So
this is basically running the one component, this one more or less, somewhere else, which is on the device, and the rest running on Home Assistant.
That's right. So the wake word's being moved over to run on this Pi 3. Now I can come in here and pick a wake word system. I have, oops, that was the wake word itself. I have 3 systems supported right now. So what this will do is when you select one, it will download and install it for you locally and set it all up. And then openWakeWord is special since we have the community repository. If you click download community wake words, it will pull those all down for you. And at that point,
the same repo that I shared. Yeah,
that was the same one. And so then you can come in here and pick from any of these. So I've chosen this one. Sure, why not? All right, how about we do? We'll try this one. You know, the repository does say like how long they were trained for and stuff. So you're going to have ones that are of varying quality.
Yeah.
All right, so I'll come in there and apply the settings. And this should reinstall, restart the server, and reconnect, or restart the satellite and reconnect to the server. All right, so let's go look at the. All right, so now it's just sitting here waiting for the wake word. So let's see, I can do, hey Zelda, set color light to red. Oh, it's already red.
Me too. You too.
Yep. I see it while I'm saying it, and that gets me to thinking of it. So anyway, the point here is that now all the wake word stuff is happening locally. So there's no audio going to Home Assistant right now, and Home Assistant isn't being burdened. And so, yeah, you can switch wake word systems, switch wake words here, all that stuff. And let's see, I don't know do you think I should go into actually putting the stuff on there, or do you think we want to jump ahead? to the next part?
As you want. We can jump ahead. You can show actually what you wanted to do, and maybe
I'll just show. So, like I said, this device is it used to be cheaper, and I have like 4 of these sitting around, so I thought I'd demonstrate it. I've also got it to work with this other. I mean, you can buy these super cheap little things to try out. You're not going to get a lot of great performance out of them, so I highly recommend, and I do this in the tutorial. This is the ReSpeaker 2-mic hat. So this thing has 2 microphones on it, and when you combine it with the noise suppression library, the WebRTC, and you turn up the volume on it, this thing does a great job. So I've had this, even with fans and heaters running in the background and music, you can still get it to activate and across the room. So the tutorial mentions this, and I would highly recommend. This is what you add to your Raspberry Pi for your Wyoming Satellite.
And it's the same process, more or less. It's exactly the same process.
Yeah, this is the same process. The only difference, if you could show my terminal one more time.
Yes, of course.
The only difference is it does.
Sorry, give me a sec. I made a mistake. Yes.
The only difference is it needs special drivers, but I've added this in the menu. So with basically one click here or one keyboard press, it will download the drivers and compile the kernel modules for you. Now, I would want to make a note that this is coming from a third party, so Seed Studio doesn't currently support this board anymore, but this is the beauty of open source. Some guy has taken it on himself to port this to newer stuff. So if you do use this, check out this guy's repo. I can provide a link. It's in the tutorial, and maybe buy him a coffee because he did a fantastic job keeping these old boards, cheap boards, alive.
Cool. I saw a question that we can answer right now. I saw that VAD is disabled when local WordWord is selected.
There is a PR for this. So I suppose, yeah, it would make sense because the VAD usually is much cheaper CPU-wise to run. So yeah, this is something I'd like to add eventually so that you basically run the voice activity detector, and then only when it's speaking, then it bothers the WakeWord system with the rest of the audio. But for now, the WakeWord systems effectively include VADs inside the models. So it's not something that's required.
And also, it's less important because you're not streaming the audio to Hub Assistant.
Yeah,
so.
Yeah. It would mostly be if you want to just save a few CPU cycles on the local board, which I can understand if you're doing like a dashboard scenario. Yeah. I've had that where on a Pi 3 it's kind of straining to run a full GUI plus a voice assistant.
Yep. Shall we move on?
Oh, someone asked about does it work with all ReSpeaker boards? This is only tested so far with the 4-mic hat and the 2-mic hat. And there are services in here that will also enable the use of the LEDs on these. But those are the only 2 boards I've tested with. I haven't tried the USB ones yet.
Okay. Cool. So that was like the Wyoming part, which is Raspberry Pi based. You saw like local WakeWord, etc. We are going to go into the ESPHome based. That was the slide more or less because it's going to be a full tutorial. ESPHome. So I'm going to show you a bit the components that we are going to use. We are going to build a voice assistant. What we are going to build is the insides of the Walkie Talkie, or the insides of the AL 9000 that you may have seen on different videos, or because all of them are using the same components, the inside of the droids that we saw at the beginning of the video. So almost all of the devices that we built were based on the same components. We are going to use the components that are there. That's it. So let me just open another camera. So before we build it, I'm going to show you the components. I will present you the components. I can remove that for now one second. I will present you the components. I will show you the components. We will build it, and then we will configure it on the software side, and we will test it. The only thing we will not do is we will not make a nice casing out of it. But you will see that at the end, it's going to be pretty close to having a full product, more or less. All right, so let's start by the components. The first thing that we are going to use is an ESP32 board. Any ESP32 board will do. I will just kill 2 birds with 1 stone because I saw the question a bit on above. There is a new kid on the block, which is called the ESP32S3 board. Of course, you will not see the name, but it's the ESP32S3 board. Sorry, S3 chip. Everyone is doing the board. There is the name there. And these boards are supposed to be, I mean, they are more recent. They just came out. They are more powerful. The problem is that today the support is very experimental. And to be honest with you, it's very complex to create a voice assistant using ESP32S3 board, because we are actually working on them right now, meaning that it is undocumented, etc. Just so you know, like the only devices that has an S3 board that we support is the box. That's the board that is on the box. We made specific code for the box, so that works. But if you want to start from scratch with a board like this and you want to create a voice assistant like what I'm going to show you, you may actually have a few, you may have hit a few roadblocks. Just so you know, because we go ahead.
I was going to say for the future, like I said, these boxes contain the S3, and in the future here, we are working on local wake word detection that runs on the S3. So that wake word detection won't run on the older ESP32 boards. So yes. There's a few hiccups right now, but if you're buying something new, you might want to really seriously consider the S3, or the easiest thing is to get the S3 box through.
Yes, the S3 box is nice. And just so you know, we are working right now on the on-wake word detection, on-device wake word detection for the S3. Well, for now, the S3 box, but soon the S3 boards, just that for now, it's pretty complex. So to come back, for now, we are going to do a standard voice assistant with regular ESP32 board. The next thing that we need is a microphone. We are going to use an I2S microphone, which looks extremely small. This is it. I2S microphone. We are going to use a very small pair of just a speaker, which is a very bad speaker. You will see that the audio quality is very bad. And to power the speaker, we are going to use an I2S amp, which is this board, very small I2S amp. I will show you like all the product pages of that. But basically, you plug the speaker on one end, and then you plug the. You will see, because we are going to do all the wiring together. But that's about it. This is the components that we are going to use, and this is the component that are on the Walkie Talkie, the AL9000, the Droid of Pitaya, everything more or less. I think this microphone is very, very well known. You have a lot of tutorial online with this one. So let's start by that, actually. Let's show the product pages first. That's a very bad layout. Give me a sec. Yeah. So the ESP board that I'm going to use is this one, the ESP32 Feather V2 from Adafruit. Very well documented. You have like all of the pinout, etc. So this is why I choose it. The microphone is this one, which is the ENMP441, which you can see also the pinout. And the amp, the I2S amp, is this one, which is the Max 98357A from Adafruit. So you find them from a lot of shops, actually, this one. All of the pins and how to connect it. So let's start, actually. Let's start to show. Normally, we do that on the board. Actually, it's already created. It's there. You can see it on the top of the screen. I'm going to do the wiring first on the screen, just because it's a bit simpler, and then we will do the software because otherwise we are going to be there forever. So let's show the wiring. And I want to show you the wiring. I want to show you also how to find the information. So first of all, if you go to the product page, you can see that, for example, the I2S microphone is powered by 3.3 volts. You can see that the amp can be powered by 5 volts. It's written there. And you also have all of the pinout of the board. So we can start by this. That's the simple part. This is the component. The UI. This is the component. That's the board with all of the different pins. In case you don't know how it works, you have like all of these pins. You have like ground. You have like the 3.3 volts there, the 5 volt there. You have all of the GPIO, which are input-output pins, all of the things. You have your microphone there, the amplifier there. And this is just a LED. I just have one LED that I'm going to use for feedback. I literally like cut down a LED from a strip of diode. I can show it to you actually. I think I can show it to you. Even if it's not the most important thing, it's there. Literally just one LED coming from.
Because it came from a strip, it's to work with it on the board. You have to communicate as if it's an LED strip with one LED.
Yeah, exactly. Yeah, so it's a bit weird that I have only one, but honestly, like, I mean, this is the cool thing. I mean, I'm sorry, I'm struggling with the layout.
Hello?
Come on.
Oh.
All right. This is the cool thing is that I'm basically just using things that I already have at hand, right? All right. So for the power part, it's not that complex. I'm going to put, I have a ground line there, I have a ground line here, and I have a red line here, it's going to be 5 volts, and I have an orange line here, it's going to be 3.3 volts. Something like this. 3 volts connected to this line, connected to the input power there, the ground connected to the ground, and then the 5 volts here connected to input 5 volts, and then the ground. And that's pretty simple. This is just to power everything, more or less. So you plug the board, this goes to 3 volts, this goes to 5 volts. The LED itself is pretty simple to wire. There is just one data in port that you wire to any GPIO that you want. Like this, data in to GPIO 15. By the way, not all GPIO are made equal. Some of them have different behavior based on startup, etc. So the best is maybe to use the same than these ones, or just to look at the guide of your specific board. Normally they tell you like which board, which pins are high or low at startup, etc. Some of them are linked to the LED on the device itself, etc. So these are the things that are usually happening. For the mic and for the speaker, both of them are communicating through something called I2S, which you can find a bit more on the ESPHome dashboard. Sorry, the ESPHome documentation. You search for, sorry, my bad. Okay. If you search for I2S, you will find like the I2S audio component, and you will basically understand that it is something that is using 2 pins, and they have a lot of different names. I like these 2 sentences. They may sound weird, but I really like them because the 2 components that we are using that are using I2S, the microphone and the amp, they are using 2 different namings for both ports, and this is sentence that actually say everything. So the first one is called the LRCK, which is left-right clock, and that can also be referred as word select WS or frame sync FS. And then you have the other one, which is the byte clock, which can be referenced as SCK for serial clock. We don't really care. Honestly, like I don't really care because I'm just using it. I don't really even know what it is about.
I'll say briefly that I2S is intended for pushing stereo audio basically over a handful of pins. And so that's what the left-right is doing. It's saying left channel, then right channel, and then the bit clock's just saying here are the bits, and you'll also find a data pin on all of these that actually carries the audio itself. Exactly,
yeah. So this is what we are going to wire. So I just use colors for simplicity. So you can see on one end we have like WS and SCK. On the other end we have like LRC and BCLK, which are what was on the page. It's just that it's different things. So I just blue and green is the I2S bus, more or less. WS, SCK. And then the SD is the data pin, which is going to transmit the audio signal. And all of them are going to GPIO. I just picked the first ones that were on the top. Just for the mic, it's almost over. There is 5 pins that we dealt with: power, ground, data, and the I2S bus. We just have this LR. If you go to the documentation of this one in particular, but I just want to say it because everyone is using it. If you use a single microphone, that's how you do it. You just ground this LR. If you use 2 microphones, you do something else. But on ESPHome, you don't really benefit from having 2 microphones. So for now, I'm just going to ground it.
No, I think actually, we just basically throw away one channel anyway. I think so don't bother.
I think so. All right. For the amp, it's kind of the same thing, more or less. LRC and BCLK is the I2S bus, so they are green and blue. And then you have the data in, which is the one that's going to transmit the data from the board to the amp to the speaker. So it's more like a data out when you think about it. And then you have 2 pins that are not used. For this one in particular, if you go to the documentation, you find that they are used for other pins to change the gain. So you can ground them or put them to 5 volt or to something, and basically you change the gain, but I don't really want to do it. So by default, it's a particular gain, and you can just use it that way. And so that's the full diagram. And so this looks nice because all of the wires are nicely done. And so this looks like this when it's a bit less beautiful. You have the microphone there, the LED there, the amp here with the speaker, and the board inside. And everything is color-coded, but I'm not going to show everything. You have the 2 I2S bus, blue and green. You have the data port, the data cable for the speaker, the LED, and the speaker, the LED, and the microphone. Orange is 3.3 volts, red is 5 volts, black is ground. I tried to make this as close as possible as the diagram. So this is like step 1, more or less. You just follow the documentation and you just wire everything up. I don't really have a lot of recommendation there. Maybe one recommendation that I can give you is to have at end a really this is for people that never did that, but it's very cool. A small how is it called? These things a
Multimeter.
Multimeter, yes. There is usually always one option on the multimeter that is continuity, which is basically if you touch the 2 cable, it's going to make a small beep. I don't know if you can hear the beep.
Mm-hmm.
And so the things that you can check are like the base one, like the very basic one, like are all the grounded. So if I start to poke around like the ground, like this is a ground and this is supposed to be a ground. Ground. There is a mistake. Yeah, ground. This is a ground. This is supposed to be a ground. This is supposed to be a ground. Yeah. So you can do that a bit everywhere to see that, yeah, at least like the ground are cool. You can also do the power line that this is supposed to be 5 volts and this is also supposed to be 5 volts, etc., etc. Like the base one, so that at least you know that you don't have a short when you are just plugging the thing in. I think that at least checking. I don't know why it's focusing on the cable itself. I'm sorry.
Yeah, it definitely likes to do that.
Yeah, at least checking the ground and the power line to make sure that you don't have, right, actually just to tell you, like before we did the rehearsal and I checked and nothing was working and I didn't understand why, and I just one of these 2 cables were switched, so I was basically grounding a power line. I mean, it's 5 volts, it's not going to make a lot, but I think that it's more or less it would actually have killed something, especially the microphone. I think it's pretty sensitive.
Some people are asking, is this the same as what's in the M5 stack
I think so.
Echo?
No, sorry. Microphone is going to be much better, miles better, I think.
Yeah. So, and this thing has a ESP32 Pico, I believe. It's obviously this couldn't fit that whole board there.
I mean, yeah. Just so you know, like, I mean, this looks. I mean, let's face it, this looks bad, right? This thing, I can wake it up across the room with one microphone that can fit inside my thumb. I can literally wake it up from outside, from across the room, a big room. I mean, so the microphone is pretty good. The mic is the speaker is bad. Let's face it. This is bad.
I mean, just like with the re-speaker board, you know, it has a JST 2-pin connector. Like you could connect an actual decent set of speakers to this.
I don't know. Yeah, I think so. Yeah, I don't know how. Myself,
I don't know either. I've never bothered with but you could. I mean, it's just the same kind of thing. If you had externally powered speakers, is what I mean. Then you should be able to connect something nice if you wanted that. Yeah.
All right. So now let's actually go to the software side. So I'm going to keep this there. Okay. So you're going to see it, and I will jump between this and the software. So the first thing I'm going to do is I'm going to plug this to the computer. So you cannot see the other side of this cable, but I'm just plugging the whole board to the computer. And now we are going to jump into the Home Assistant. So to create a voice assistant, to create an ESPHome device, you need an add-on that is called ESPHome. ESPHome is an add-on that allows you to create devices by declaring components in a YAML format, and it does the heavy lifting of compiling the code and actually uploading it on the board. So you go to add-on, and then ESPHome, and then you install it, and then you open the web UI. That will look like this. I'm just going to cheat a bit, and I'm going to add another instance of ESPHome. Because ESPHome, the compilation can take a bit of time, and I don't want to be there forever. I'm using my server for ESPHome. Everything that I'm doing, you can do it on a green. It's just that it may take a bit longer, which is fine. It's just that I don't want to spend too much time just waiting for that with you. Right. So we're going to add a device, and I'm going to name it. Give me a sec. I'm sorry. Yeah, okay. I'm going to name it Voice Assistant Prototype. Next, it's going to ask me to connect. Here, a screen will pop that you will not see because it's off the browser, but it's basically asking me the serial port that I just connected to the browser. I click on connect, and it's basically doing the initial connection, initial flashing, sorry.
And then browser is important here for if you want your browser to be able to talk and flash one of the devices, you need to be using a Chrome base or an Edge-based browser.
Yeah. Yeah, I see someone commenting on my naming. Yes, I think I have 7 or 8 different. So this is a WakeWord. This is a WakeWord. Sorry, this is a voice assistant. That's a voice assistant. This one is also one. This one is also one. All of them are voice assistant, more or less. If you are curious, the WakeWord test voice assistant is on my desk and looks like this. And I've been using it for testing everything. And I will show it to you afterwards because that's maybe the second step that you do once you finish with the spaghetti of cable that we have there in front of us. All right. So
what's happening right now? What's
happening? So we are flashing on the board a config of ESPHome. You may think like, wait, but we didn't do anything, right? We didn't set anything. And that's correct. We are flashing a vanilla configuration of ESPHome, which has nothing on it. But at least it's going to talk to Home Assistant. And honestly, that's about it. But it's already pretty good. And then we are going to add things. The LED, the speaker, the mic, the voice assistant components, all of the things.
So one thing that's going to do importantly here is you've set up this ESPHome instance and you've given it your Wi-Fi credentials.
Yeah.
And so ESPHome is going to flash those on the device so it can connect to the Wi-Fi and then connect to Home Assistant from there.
Yeah.
You can also do this through the, what is it, web.es? Can't remember off the top of my head.
Web.ESPHome, yeah.
Yeah, web.ESPHome.io. If you go there again in a Chrome or Edge-based browser, you can flash directly this thing and put in. Yeah, and after it's flashed, it'll actually ask you for your Wi-Fi credentials right there. So this is possible just through that.
Yeah. So it's over. If I go to Home Assistant now, and I go to Settings, Device, I should have a new device that has been popped up, and I can configure it. If you use the add-on, this is a one-click setup. You just click one click, submit, and it's done. Because I'm not using the add-on, and I don't want to lie, there is one more step, which is they ask me the encryption key. You may ask what this is. If you go back to the ESPHome dashboard, there is now a new box, which is the one that we created. If you click on Edit, you will see, so that's my Wi-Fi credential. Everything is obfuscated, but this is the encryption key that will be used for the connection, the local connection between the device and Home Assistant. And so I'm just pasting it, and you don't need to do it if you are using just the add-on. I'm going to put that in the office also. And now we have a device with nothing on it. More or less. For now, we have nothing on it. And this is the test bed or the sandbox to start adding stuff on that device. And we are going to start by adding the LED because it's a simple case. We are going to add the LED. We are going to control the LED. And then we are going to add the voice assistant components. I want to do that because it's always kind of the same thing, more or less, which is you go to the documentation, ESPHome, and you search for what you want to add, which is a light. And then you start to look for the documentation. There is always something called the core, which is all the options that are coming that will be common to all the different lights. So we can see, for example, well, first of all, there is the keyword, which is light, and then you have like I don't know, default transition length, which is 1 second by default, or like effects. For example, there is effects somewhere. effects. You can say, okay, I want a pulse effect, for example, that's going to pulse the light or things like this. And then all of the other boxes that you see there are what we call platform. So you can have different platform. For example, if you have a RGB light, which is not what I have, it's like literally a light with like a red channel, a blue channel, a green channel, and usually like a 5 volt or a 12 volt channel, then that's a platform that you can use. And usually it's always like platform and the name of the platform. And then you have other options that are specific to that platform. Here I'm going to use this platform because the description suits me well. It's like used to drive most of the addressable LED strip, so that's perfect. And so I'm going to start copying a bunch of code. Because I don't want to jump back and forth between like all of the windows, I will just show you a bit the thing, but it's more or less everything is there. So this platform asks me for a pin, which is the pin of the data pin, which will be, you know, like, I don't remember, 15, like the pin of the LED. And then it's asking me for number of LEDs, so it would be 1, RMT channel. There are things that I don't know, and usually the description is very well done. For example, this one is if you use multiple of them, you need to have different channels. So I don't, so I will put 0. The chipset, this is usually known when you buy the LED, so that's this one. The RGB order, honestly, for this one, I just tested. I started by RGB, and when I was turning on red, it was blue, and so I just, you know, do the small round robin, and so on and so forth. Eventually, at the end, it's going to look like this. I will show you, and I will explain you, of course. That's the goal, right? Is to explain you everything.
Real quick, I want to tell people, if my recommendation, if you're getting into ESPHome, document, write notes to yourself about your process. Yeah. It works so well that by the time you come back to it 2 years later, when you're changing your device, because it's been rock solid, you've forgotten everything that you had done previously.
Okay, so light, which is the correct platform, the one that we said, the order of my lights are GRB, so good to know. Pin 15, the one that we said, number of LED 1, the channel 0. I give them a name, status LED, an ID, LED. Transition length was set to 1. We are going to use it as a status indicator for the voice assistant. So I put 0 because I want to be a bit faster. And then I created 2 effects, one slow pulse, which is going to pulse slowly, one a fast pulse, which is going to pulse a bit faster. You will see why, but we are going to use them for the voice assistant. And then it's always the same process. You save, you install wirelessly because it's already connected to your network. This is compiling everything. This is the step that, if you are on a green, it may be a bit slower than this. And then it's going to upload it to the device.
And of course, the first time you do this is going to be longer because it has to pull down the code, but the second time it'll build upon what it already has.
Yeah, so every time you add a new component, for example, that was the first time I was adding light, then it's downloading light. So now it's connected to the device. If I go to the device, now I have a LED, which the name that I created and the effect that I created. Of course, we are going to see that. So I'm just going to do this weird one, which is this. It's a bit weird, but at least you can see it. So if I turn on the lights, this is turned on. I can change a bit the color. So let's put it orange or blue or green or red. And then the effects, we have slow pulse, which looks like this, and fast pulse that looks like this. So not really related to home assistant, to voice assistant in itself, but this is more or less the process of how to create anything on ESPHome. You look at the documentation, you think about all of the options that you want, and then you just put them on YAML, and then you try it out. So now let's go to actually the voice assistant part. Again, just because I don't want to spend too much time jumping back and forth, let's do a big run on the documentation, what you need, and then we will just show you on the firmware itself. So if you search for voice assistant, you will see the components, which is called by there is funny, like there is not the keyword, which is voice assistant. This is actually funny that we don't have the keyword voice assistant.
Oh, yeah, maybe you should.
It's yeah, voice assistant. Okay.
There it is.
And then there is so many options, but actually I'm going to explain them all to you, but not now. But we are going to show them all. It's super important if you build things. But the most important one is that you need a microphone, you need a speaker. Microphone is required, speaker is optional, obviously. You need to speak it, but then the response, it's up to you, right? Maybe you want a silent voice assistant. Microphone, speaker, we want both. Then use WakeWord is going to be set to true because we want to use a WakeWord. Then all of the on underscore, which is 95% of what it is, are called triggers, which is a keyword that will be used to perform actions on device. You can call them automation. They are automation on the device itself without using Home Assistant. This is how we will pair the LED to the state of the voice assistant. And then you have a few things like noise suppression level, auto gain, and volume multiplier. It's the same that Mike showed you. So let's start. No, actually, no, let's not start. Let's actually dig deeper. If you go to microphone, there is one platform, which is the I2S microphone, which is what we want. And you can see also a bit of things. You can read everything, but normally everything is very self-explanatory. For example, you have like an ADC type that says like, oh, if you use I2S bus, it's this one. So it's always pretty self-explanatory, I would say.
And there's a big scary warning up on the top I wanted to mention in red. But it is important that a voice assistant running does take significant resources on a board, especially a lower end board like the ESP32. So beware that if you're trying to shove everything on a single board, you might have a bad time. Especially
Bluetooth proxies, for example. So just know that we are pushing a bit the envelope of what's possible on this ESP32 board. The ESP32S3 board will be better, but for now, again, it's not a walk in the park to create something with the S3 board. So it is what it is. If we dig again deeper on the microphone, we need to give an ID of the I2S audio bus itself, which is just the two pins that we were showing before. So that's more or less what we need to do. We have voice assistant, microphone, speaker also, which is the same thing, speaker. And then the speaker has one platform, which is the I2S audio speaker, and then the I2S audio itself. So let's see everything. Sorry, I just looked at the chat and I have one question. No, actually, like the question was like, is the ESP S3 box free setup process the same as you do now? No, because we have something very cool for this one, which is called ready-made project, which is on ESPHome. It's there. You go to ESPHome, like the root URL. It's this one. It's a ready-made project. And you click on the S3 box and you click on your version and you click on connect and it's done. So like this 30-minute tutorial is 1 second because we are creating the firmware for you.
Yep. And again, in a Chrome or Edge-based browser, that connect button will show up.
And it's actually pretty customizable because you can change the picture on the board. You can look at chapter 5 if you want to see that, but yeah, it's much simpler. Here, what we are doing is we are more showing how to create your own device, anything you want.
And that includes the ability to change the picture too that shows up.
Yeah. So, okay, so let's do what we said. We will have a voice assistant. Well, okay, sorry. First thing, I need to start by a bit of dark magic. I will explain you the dark magic, but I still need to start by a bit of dark magic.
And if you love dark magic, hit like on that below the video to help us.
Just a tiny bit of dark magic. We support two framework on ESPHome, Arduino and ESP-IDF. ESP-IDF, I think, is smaller, more lightweight than Arduino.
Yeah, that's more of a question for the ESPHome team, but it is something that's necessary for us to do the audio processing that we're doing. It's kind of a different framework for the entire board.
Yeah. We are changing the framework, and then the other part of dark magic, which I'm sorry, but we need to, is we are going to instantiate a component that is not documented for now, that is called ESP-ADF, which is an audio framework from Espressif. And because it's not documented, we need to reference an external component. It's fine. It's never going to change. It's there. I will share the whole framework with you, so just know that it's there, and that's it, right? Like, that's the end of the dark magic. I'm sorry about that, but this is necessary. Okay, so the I2S audio is actually pretty simple. We have two of them, and it's just like these two blue and green pins that we set up before. These ones. So we have one that I called I2S in, which will be the microphone, which basically is pin 26, 25, and we have one out, which is pin 12 and 27. And this is why having a nice diagram is better. And bam, that's it. That's the I2S part. Now that we have the I2S part, I can start to reference the microphone, which is just going to be, I want a microphone with an I2S audio microphone, a few options, the correct I2S bus that I referenced there. That's it. All of the other options, you find them on the doc, and they are self-explanatory. Speaker, same thing. I want a speaker, I2S audio platform, the correct I2S bus. The data pin. This pin, the 33 and the 34, are the yellow pins. So if you go back to the diagram, 33 on the speaker side, and this one, 34 on the microphone side.
Now, wouldn't it be awesome if AI was good enough that you could take a picture of the diagram and generate a YAML for
and say like, do that, yeah, do that, please. I think we finished actually like all of the pins now, because we have all the I2S pins, we have the data pin for the microphone, speaker, and the LED, so kind of done. And then the last component, of course, the cherry on the cake, which is going to be the voice assistant. Very simple. I'm going to put a ID, voice assistant, microphone, speaker, and use WakeWord. If I do this, and I did when I started to rehearse this live stream, I spent 30 minutes trying to understand why it was not working. It's funny because, you know, like I've created so many of them that when I trim down some things, I kind of forget something. You need to turn it on, right? It's something that you need to turn on. If you go to the doc, you have actually like a very small number of action in the voice assistant part. Voice assistant. You basically have 3 actions, which is start, which is mostly used to start once, which is going to be like, I mean, either if you really want to start it once, but mostly like push to talk, like a talkie-walkie or something like this.
Yeah.
Start continuous, which is basically saying every time a pipeline ends, please do it again, which is good for WakeWord, and then stop if you want to stop it.
Yeah, so yeah, the voice assistant by default, when the ESPHome boots, it's off. It's not doing anything for resource, conservation. And so before it processes anything, you need to tell it to turn on.
Yeah. And so for now, because we are doing like the very base and I just want to show you it working, I just went the very easy route, the simplest route, which is I'm using a trigger for the voice assistant, which is on client connected. I will explain them all to you afterwards. But this is, I mean, technically, you can read the doc. And it is when Home Assistant has connected and is waiting for the voice assistant command. So basically, it's when the device is connected to Home Assistant. And so as soon as it's connected, I'm asking it to start continuously because I have the WakeWord part. So that's really like the simplest voice assistant.
So this one will be an always streaming one, right?
Yeah, exactly. There is no VAD, yes, for now. So right. Yeah, always streaming, exactly. There is no connection between the LED and the voice assistant, so there will be no feedback, nothing. I just want to show you the things that we did, and then we will start to pair everything together. So I saved it, install wirelessly. This is the part, that's the part that may be a bit long if you are on the green. The part where you integrate the ESPHADF components the first time. It's super big. Mm-hmm. But I mean, that's just life. And you do it once, right? You compile only once. And this is where like I mean, again, like everything works. And I compiled the voice assistant on a yellow for a very long time. And you don't compile this every day. You just compile it once and you let it sit. And then you can do many, many of them. Okay, uploading.
I wish the Wyoming Satellite had over-the-air updates.
Yeah,
that would be awesome.
Yeah.
Maybe
okay, if we go to the voice assistant, well, actually, it's not started yet. Now it's started. Let's refresh. You have the same entities that Mike showed. You have like the assist in progress input, sorry, no input, Boolean that is going to be either off or on, depending of if the pipeline is in progress. Which remind me that one of the questions was, can we turn on a light when the wake word has been triggered? Yes, we have a input Boolean for that, so you can basically create an integration, an automation for that. We have the pipeline with all the pipeline that we created before. And that's about it. So now there is no feedback. So if you look at the top of your screen, you can see the whole breadboard. Nothing is going to happen because I didn't pair anything. The only thing that's going to happen is this input Boolean is going to go to true to on when I'm saying the wake word. For now, that's the only thing. But let's still test it. What's the wake word? Okay. Okay, Nabu. Turn on the bunny.
Sorry, I couldn't understand that.
Okay, Nabu. Okay, Nabu. Turn on the bunny.
Turned on the light.
Okay, so the bunny turned on, and I just, of course, Murphy's Law, my second webcam, my second camera just died, which is fine because I didn't have a lot of things to share, so we will do it with only one camera for now. So my bad for the nice overhead shot, but I've been rehearsing 2 times, so the camera has been on for like 7 hours and didn't like that. So I will let it sit a bit, see if we can. I mean, the nice overhead shot were over, so I will just stop it. It's sad. It's fine. So okay, so you saw. Sorry, I was a bit confused. It's working, but again, like I have 0 feedback on the on the voice assistant itself. Like everything is just for now. Like I have no LED feedback, nothing. But technically, it's working.
And
so,
I would say too, you also have 0 audio cleanup happening. So this is basically taking the raw audio off that tiny little mic and shoving it in without any kind of cleanup.
It's basically like a bare bone everything, more or less. It's like the very simplest one just to show that it works, right? So, okay, Nabu, set the bunny to red.
Sorry, I couldn't understand.
2 things interesting. One, you saw that it took a lot of time to answer, which is the fact that this is what Mike is saying. I have no noise suppression, so the mic is constantly picking noise and doesn't know when to stop. So sometimes I have very long delay before something is happening, which I will clean afterwards. And also, it's pretty bad for now. Okay, Nabu, set the bunny to green. I mean, it's working. So let's do a few things. Like let's basically continue to tune this one. I will do 2 things. The first one, which is pretty easy, which is to add these 3 things: noise suppression, audio gain, and volume multiplier. I have set them on my side to pretty aggressive values. They work. And I will recommend them for people that are using the same mic. I would also recommend just to try it out and to see a bit for yourself if it's not working. But
yeah. Now there's a debug recording feature in Home Assistant where you can have it record all the audio and you can listen. It's not very user friendly at the moment, and we are working on the capability to record a sample from a device so you can. I mean, because really, once you hear for yourself, you'll immediately understand the difference between having the noise suppression on and off. It's night and day.
So basically on this small mic, it's pretty simple, right? Noise suppression to the max. And I'm bumping the volume so much. If I do that, I'm able to just wake it up from across the room. And also another test, which is nice, especially if you start to increase the volume. I'm able to wake it up from across the room. And I'm also able to wake it up screaming on the microphone, which actually means that it's actually pretty well tuned. So that's one thing that we can do. That's pretty simple. I'm going to save, not going to study it yet. The second thing is to actually start pairing the LED to the voice assistant. LED is just one excuse for me to explain you how the voice assistant works, because if you want to create any kind of ESPHome device, you may want to do other things with it. Paul is moving the wheels of his robot when something happens on the voice assistant. He's moving the head when the voice assistant is replying or something like this. You may think like, I want to do that. I really want to do that. And so to do that, you need to understand all of this trigger, this on trigger. There is a lot of them. technically our voice assistant is doing a lot of things. And so I'm going to spend a bit of time on explaining you what is happening inside the life of a small voice assistant in ESPHome. And then we will pick the one we want to use for our LED. So a bit of theory. That's kind of my goal. I'm secretly teaching you things while I'm creating a voice assistant.
And these
Oh,
these same stages are available on the Wyoming Satellite too.
Okay,
So
good.
learning this will help you everywhere.
Yeah. By the way, like you don't need this diagram. Everything is on the dock of ESPHome. It's just that reading it and seeing it live is not the same thing. So let's go. I just need something. I need a red. Yeah, perfect. All right. So when you start the thing and nothing is connected, there is one trigger that is on client connected, which means, okay, now it's connected to Home Assistant. That's the first thing that it does. Then you start it. There is an event on start, and then it's idle, meaning that it's waiting for the wake word. When you say the wake word, it sends another event, which is on wake word detected. And then you will see that there is like this purple light step. These are basically the steps that are very fast, almost instant, because it's one component handing over the work to another component. So this one is more or less like the wake word component saying, I did my job. And this is the STT component saying, I'm starting. So we have a step in between that is instant, meaning these two things are happening almost instantaneously. You will see the same thing for the handing over between all of the steps more or less. So, okay, you say the wake word. You say like, okay, it's here. The wake word is detected and it's starting to listen to the command, more or less. I'm going to make a big line there because I want to come back to that later. Then it's waiting for a command. If you don't say anything for like 30 seconds, it's going to wait there for 30 seconds, especially if you have a good noise suppression. If you have no sound, it's going to wait there. As soon as you start to talk, you have the voice activity detection that starts. And now we are actually detecting speech. When you finish to say your speech, we have a voice activity detection and trigger that is triggered. I'm going to do another big line there. After the complete speech is actually it's in between because it's streaming, so it's doing it at the same time, but more or less when the speech has ended, there is still a task to be done, which is translating the speech into text, which is the end goal of the SCT components. This can actually take a bit of time if you are on Whisper on a green, for example. This is the part that can take a bit of time. At the end of this, that's the end of the STT thing. So it ends over to the next component, which is the conversation agent. So this is also a step that is very fast. So it's like STT has ended. Now we are starting the intent recognition. So basically, we are going to parse the text to understand what to do. Parsing the text, understanding what to do, and doing it usually is super fast, especially if you turn on the lights. If you start to trigger things that are on the cloud, like ChatGPT, etc., that could take long. It depends what you do with your voice assistant. This is usually very fast if you just turn on the light. If you ask ChatGPT to pair your calendar event with something and then something else, then it may be long. It depends on what you do. But you have basically an event at the beginning of the processing of something and at the end of the processing of something else. And that's the ending over between the conversation agent and the TTS part. So it's like, my job is done. Okay, I'm starting mine. The TTS is a bit more complex because Home Assistant is going to start generating a response. It's going to finish generating a response, which is going to be by the form of a URL. This is the part that can be a bit long if you use Piper. And for example, you provide him very long responses. For example, ChatGPT plus Piper is awful because ChatGPT has very long answers. Piper takes a lot of time. So, for example, this is a combo that doesn't work well.
Luckily, when the TTS is cached, this is a very fast step.
Yeah, exactly, and this is why we are caching it actually.
Mm-hmm.
And then when this part ends and the URL is generated, the device starts to stream. So we have streaming events. I'm starting to stream. I'm ending to stream. And I'm going to put two things there. All right, so there is a lot of events. What I'm going to do is I'm going to say everything that is before on listening, it's kind of, I'm going to call it idle. It's kind of like I'm idling more or less. As soon as you say the wake word, up until the speech is over, that speech is over, meaning that I'm putting aside the processing itself. I'm going to say that this one is listening. Listening. So I'm listening to something. Then all of this thing is processing or thinking, which is the mix of many things. You have like the end of the STT part, which is the processing of the speech into text. You have the transformation of the intent into action, and you have the transformation of the text into speech. All of this is thinking. When the stream starts, this is replying. And this is the event I'm going to use for the lights. So I'm going to use on listening, on STT VAD end, on STT stream start, and on TTS stream end.
And the cool thing is, like, if you don't like this, like, you don't have to just go complain to a company on Twitter. Like, you can just change it.
Yeah. So actually, I should have made a video when I was understanding this, because that's a mess to understand. I made my light change color for every steps. That was actually pretty funny to see, because it was like I was saying okay Nabu, and then after it was like done. Very funny to see all of the lights. But yeah, so let's do that. Actually, let's just build that. For now, it's going to be pretty simple. So let's for now put all of the different triggers. So we have on listening, we have on STT VAD end, as I said. We have on TTS stream start, on TTS stream end. And that's it for now. So what we want to do, let's start by the beginning. Actually, you will see that now it's becoming complex because we will have to declare things in different places, which is going to be fixed at the end of the tutorial. I will provide you a cleaner way of doing things, but you will see that it's a bit messy because, okay, so first, what do I want to do? When the wake word is, when the device is ready to listen, I want just to have a nice white color like this. So when it's connected, so at the beginning, I want to start it and I want to put the light to white 20%. It's like a very dimmed white. When the listening starts, I want to put a slow pulsating blue. Like this. So I'm going to turn on the light to 100% slow blue. When it's thinking, I want a fast pulsating blue. And when it's replying, I want a solid blue. I'm going to say kind of Alexa. Don't want to say that, but mostly like kind of Alexa. And when it's finished streaming, then I want the same thing as the idle one. So we are starting to declare like the idle state twice, which if you are a programmer, it's like, I don't like this. I don't like this either. And this is why at the end, we will actually have a cleaner way of doing this. But at least you understand it's actually pretty simple to do. Install wirelessly. This is when I need to do like gymnastics because of this freaking camera that died. Sorry about that. I think I'm going to do this. I think that's enough. And I will just do that. Yeah, okay. Give me a sec. I will just do MacGyver thing. It's going to work. It's going to be okay. We are going to manage this live stream. Okay. So it's over. I'm just waiting for the lights, for the logs. Okay. So nothing has changed, of course, on the Home Assistant. If I just increase the size of my camera.
Someone asked, does the save or install have any error checking for syntax? Yes.
Yes.
It will not let you install broken stuff. Yeah.
So this is the, actually, you know what? Let me just turn off the two face lights that I have so that it's maybe a bit darker and you may see a bit better. Yes. So this is the dim light, the dim white. And so again, slow blue means it's listening. Fast blue means it's thinking. And solid blue means it's replying. Of course, I'm sorry because I have only one camera. You will not be able to see the result at the same time. But okay, Nabu. Okay, Nabu. Turn off the bunny.
Turned off the light.
I don't know why I'm saying the first command is sometimes a bit slow. Okay, Nabu. Okay, Nabu. Turn on the bunny.
Turned on the light.
Yeah. I don't know if you were able to hear that or if it was too.
I could hear that.
Yeah.
And of course, just like we've showed previously, if you wanted to switch over to framboise as your WakeWord,
exactly.
it would be as simple as changing the pipeline.
Yeah, exactly. Yeah. So that's the device and that's the bunny. Okay, Nabu. Turn off the bunny.
Turned off the light.
Yeah.
Can you actually show that? Could you show switching the pipeline?
Yes, of course, I can. No problem.
So people can see just how easy it is to test this stuff out.
Yeah, actually, you know what? It's interesting because I saw a lot of questions about that, and I think it's interesting. Let's just look at the logs of ESPHome quickly. A pipeline is, even if, for now, I don't have a VAD, so it's always streaming, right? So a pipeline starts when a pipeline ends. So right now, it's waiting for the WakeWord, and I don't know if the log are still live, but at some point, it's going to time out and say, okay, I didn't find the WakeWord, so I need another pipeline. Mm-hmm. And so this means that at any point in time, a pipeline is always running, which is interesting because this is the WakeWord that is currently in. If I change it to framboise, it's not going to work. I will have to say once, okay, Nabu, to kind of flush the pipeline once.
Oh, I thought we had that fixed.
I don't think so. So let's try.
Let's try.
Framboise. Okay, Nabu. You see? Okay, Nabu is actually replying. Sorry.
Well, okay, we got to fix that.
I think it's a bug, but it's fine. And now it's going to be the other one. Framboise, turn on the bunny.
Turned on the light.
I actually didn't know that we were trying to fix that. I thought that it was always normal, I would say. But okay, if it's a bug, it's nice.
Yeah, it'll get fixed. That's it fixes that it doesn't do that on the Wyoming Satellite. So
yeah, okay, cool. All right, so we have a voice assistant. It's always listening. Always this white light that is saying that it's listening, which is cool. But I think one of the first things that you want to do when you create a voice assistant is just to be able to mute it. That's something like pretty simple. So we're going to add that as one of the last steps before sharing the full configuration. So again, one last time, but for you to because it's always the same kind of logic. Give me a second. I just need to turn off the bunny. Actually, Framboise, turn off the bunny because my face is on. Okay. So always the same process. You go to the dock, you find what you want, and then you do it. So I want a switch. I want a switch to be able to have, a switch, more or less a switch on Home Assistant that will mute the voice assistant. We need to understand what mute is, and we need a switch. So the switch, again, it's the same thing. It has a core and some platforms. We're going to use the template switch, which is like just something to say like it's going to be on Home Assistant. Pretty easy. You can templatize the state, but we are not even going to. It's optional. So again, you read the documentation, you do all of the things. At the end, you are able to create a switch, which is pretty simple on this side, which looks like this. So let's go back to the dashboard. Let's create a switch. Wow, so many lines. So let's go one by one. It's a switch platform template. I'm going to use it. I'm going to call it use WakeWord. Optimistic true means that I don't need anything to. What's the exact definition of optimistic? Because I understand it, but I'm always struggling to explain it. Actually, it's on the template.
Is it in core?
No, I think it's on optimistic. Yeah, this basically means that it's not going to wait until the Lambda to know what is the state. So when I turn it on, it's on. When I turn it off, it's off. It's a one-way switch, more or less, which is what I want. Perfect.
Yeah, that's good.
Restore mode means like how is it going to be restored? This is a long thing to say like it's going to be on by default, but if I'm able to find the value, it's going to be restored to the value. So if I turn it off and I unplug the ESPHome and replug it, it's going to be off. But by default, it's going to be on. When I'm turning it on, I'm going to run the voice assistant.
You're
Sorry,
saying
I'm
it's
going
not
to,
running.
I'm going to run the voice assistant. Just one small condition, I'm saying like I'm going to run the voice assistant if it's not already running. If it's already running, I'm not doing anything. Okay, I'm already starting to add complexity that I should not add in this step. I should add at the end. So I'm just going to remove it actually. For now, let's do it very simple. When I turn it on, I'm running the voice assistant. And then I'm also turning on the light, again, to the idle state. So now like the idle state is declared 3 times. So if I want to change it to like a purple, I need to change it 3 times, which is becoming a bit annoying. And when I turn off the switch, I just want to stop the voice assistant and stop the LED. For now, that's it. I think that's it. No, that's not it. On the connection, right now I'm just starting the thing. I just need to say if the switch is on the right state, which is if the switch is on, then I'm going to turn on the voice assistant, because otherwise I'm just going to always turn it on. And technically I should also say like else, then I'm just turning off the LED, so it's always in the correct state. So okay, so it works, but again it's becoming more complex because you are adding declaring things a bit everywhere, but it's working for now. Save, install.
But this, I mean, kind of the end goal here is you have this switch that's a Home Assistant entity.
Yeah.
And so you can automate based on that. You could say, if I have a presence detector and there's nobody in the room, well, turn off the voice assistant. It doesn't need to be listening.
This is interesting. I had an error that I'm sometimes getting, and I just want to show you how to solve it, because the first time you see it, it's a bit like, what the hell? If you see things like that, like Home Assistant, ESPHome is not able to find component. Like for example, I'm not able to find like the optimistic part of the switch because I just added a switch. Close, clean build files, install. Which is going to be problematic on a green because it's going to be a bit long again. But yeah, actually, I asked Jesse and Keith why we have that, and we don't really know for now. So sorry about that, but sometimes it happens. Usually it happens when you are adding components or also removing components. If I'm removing a component, sometimes it's going to say like, I'm sorry, but I'm expecting a light and I don't have a light anymore. So yeah.
There's some cache thing.
Yeah. So now, yeah, I'm going to have a switch, right? Like a virtual switch. I see the question like, can we put a physical switch as well? Yeah, I mean, that's the goal of ESPHome, is that you can pair two. So there will be a platform for like a GPIO switch. Yeah. Exactly.
So that was on what's on the M5. Yeah. So you could have.
That's a button, but you can have like a bi-state switch, for example, and you will be able to say like when this one is off, when this one is on.
Like, that's one where I wanted to make like an intercom style thing that was, yeah, kind of like that was, but I wanted it on the wall so that the kids couldn't reach it.
Yeah. All right, so it is done. I think I'm just going to show you. So okay, now if I go back to ESPHome, to Home Assistant, I have a switch, which is, sorry, yeah, my bad.
Yeah, I can see.
I have a switch.
There it is.
Use no problem. And so the nice thing is that this I can show you right now. The light is on. If I just say, I don't want to use the webcam anymore, the light is now off. On, off, on, off. When it's on, I can wake up the device. That is weird because I didn't say framboise, but it does kind of wake up automatically.
Sorry, I couldn't understand that.
Which makes me think that on Porcupine, I have a bit more false positive than on openWakeWord. So I'm waiting for the French openWakeWord, but yeah. So this is on, so I can say framboise, turn on the bunny.
Turned on the light.
And now if I want to automate the fact that, for example, what I'm doing at home is when I'm not in a room, nobody talks to my voice assistant, kind of a security feature. I don't know if I want to call it a security feature, but so this means that when I'm not home, nothing is actually on. And I can just say, up, we'll automate on that switch. Now this thing is dead. Framboise, you can see the binary sensor to off. Framboise, this is completely dead now. And if I come back, I can automate. Turn on this. Framboise, turn off the bunny.
Turned off the light.
Someone asks, can we stream the response to our remote speaker? I believe so, yes. There's a media player option instead of a speaker. I don't know what the constraints are on that.
the constraints are very, very huge for now today, which is the fact that if you use media player, you cannot use ESPHome. So basically, no WakeWord. There is a way to do that. Someone from the community find a way. I will just give you some hints of how to do it, but then you will have to either check the community or do it yourself. But I will give you some hints about how to do that. Give me 1 sec. Voice assistant. It's a bit of a hack because we don't use the full pipeline, meaning that we will not use the voice that you put on your pipeline. You create a voice assistant with just a microphone, no speaker. One of these events as the URL of the media player. No, sorry, as the text of the response. It's usually the one. No, I think it's going to be like on intent end. I think we can see, but either this one or this one. I don't remember, but one of these two are going to have the answer as a variable. So let's go back. Oh, sorry, where is? I think it's on intent end. No, so there is nothing, so it's on TTS start. On TTS start. The text to be spoken is available to automation as a variable X. So you get the text, you do whatever you want with it. For example, you can call a native Home Assistant service to play it wherever you want. That's one way. It's a bit of a hacky way because on one end you say like, I want this pipeline with this specific STT thing, and then you use something else, but that's one way to do it.
Yeah, and I guess kind of the reason for that is the media player uses Arduino, the Arduino framework.
Yeah. So it's a bunch of consequences. Like if you want to use media player, it's Arduino. If it's Arduino, you can use WakeWord. I'm not saying it's not working. It's very, very unreliable. So like what I'm showing right now is reliable. ESPHome as a framework, ESPHadf as a component, the dark magic thing. Use WakeWord, a speaker, no media player. This is something that is working well. I'm not saying that I'm not having bugs. I'm sometimes having a few bugs. Usually they resolve automatically. So just having them on house like this, I'm never having any bug more or less.
Yeah, I mean, so there are going to be bugs, obviously. Things we built a lot last year, right? And so, we're still going to be building things this year, obviously, but I think a hope is we can take some time to make sure that we clean up a lot of this stuff and get it working really well for everybody.
All right, so to conclude, sorry, before doing that, because I just need to explain you why I'm doing more than that. What we have is working, but if you want to use the exact framework, the exact YAML framework that I have there, and you want to really put it on a device and you start to use it, you will see that there is some things that we are not doing well. There is no error handling. We have an on error, but we don't do anything. If Home Assistants lose connection, for example, you do an update, the LED is going to keep being white, meaning that you may think that you can talk to that, but you won't be able to talk to that because there is no server behind. And all of these small things that I'm going to fix, but I'm going to fix them all at once. I will explain you what I'm doing, but I will just fix them all at once because it's been 2 hours and 12 minutes that we are there. So let's start. Again, I will explain you all of this. I'm going to add 2 global variables. I will just be a bit faster. I will add 2 global variables. One that is init in progress, which is just set once to true when the thing initializes. And this is just to have another pattern on the LED when the thing boots up for the first time and like is trying to find all of the connections and Home Assistant, etc. And then it will be put to false forever. And then I'm adding a global for the phase of Home Assistant, of the voice assistant. Thinking, replying, idle, listening, error, things like this. I'm going to define the phase as substitutions. We have numbers. We don't really care about the numbers. It's just that I don't want to say like when the voice assistant is in phase 2 because it makes no sense. So I want to be able to read the code. So this is why I'm doing this. All right, so I'm going to start, again, putting a bunch of code a bit everywhere, and then I will explain you what I'm doing. I will try not to lose myself. Okay, on boot, so the first time that it boots, so first of all, the main thing is that I'm going to put all of the control of the LED on one end. It's going to be like a script that controls the LED for the whole thing. The voice assistant component is not going to control the LED. It's going to control its state. And then the script is going to control the LED. It's going to be much cleaner, much more separation. If you want to change the idle state is going to be one thing at one place. That's it. Again, I'm doing that because I want you to copy this kind of codes for other things. I'm thinking about you having voice assistant where you want to do other things when it's listening, thinking. For example, Pulse is moving the wheels when it's doing something. This is why I want to do that. So at boot, it's going to execute a script to control the LED. It's going to wait 30 seconds. And if the init is, if I'm still in init in progress, so initialization in progress, I'm going to put it to false and re-execute the script. The script is going to be executed every time because this is where all the variables come together to do like the correct state. When the API connects or disconnects, meaning when I lose the connection with Home Assistant, I'm going to execute the script again. You will see why after. When the Wi-Fi is connected or disconnected, I'm going to execute the script. Again, you will see why when you will see the script. And on the voice assistant, this part is going to be actually simpler. That's kind of the goal. When it's listening, I'm going to... Sorry, my notes are a bit weird. Give me a sec. That's the part where I should not try to... When it's listening, I'm going to set the phase to listening, and I'm going to execute the script. When it's thinking, I'm going to put the step to thinking, and I'm going to execute the script. So this is like much simpler. When it's replying, when it's idle, so when the stream the stream ends, I'm just going to put it back to idle. I'm going to add one thing, which is the on error, which is the handling of the error. And I'm going a bit fast, but I will explain you anyway what I'm doing. The error is more or less, okay, I'm ignoring the error when it's in progress because there is a few of them. But basically, I'm putting the, when I have an error, I'm putting the voice assistant in error. I'm waiting 1 second, and then I'm putting it back either in idle or muted based on if the switch is on or off. And on client connected, I'm doing the same thing. If the switch is on, I'm putting it in idle. If the switch is off, I'm putting it in muted. And then I'm executing the script. And when it's disconnected, I'm putting it in not ready, which is another step. So I'm sorry, it was a lot of code, but yeah.
So this is basically you're setting the state of a state machine.
Yeah, it's state machine more.
Calling an update method.
Yeah, that's kind of it, yeah. On the switch, so basically every time there is lights turn on, I don't want this. So when I'm turning on the switch, I'm just going to set the states to idle. That's it. And when it's off, I'm going to, I'm doing it. I'm actually starting the thing, and then I'm just putting it to idle. And when it's off, I'm just stopping it and then putting it to mute. I'm thinking about it. This could be on start and on stop. I think no, I don't. We don't have an on stop here. And so the big script, which is this one, would be the one where everything is controlled. We have like all of the steps. So if the edit is in progress, then it's like something particular. So for example, I'm putting a green, fast green. You will see it. If the Wi-Fi is not connected, if the API is not connected, then everything goes back to black, which is like a turn off. So this means that when I'm upgrading Home Assistant, it goes to black to turn off, which is cool because I see it. And then we have all of the steps, and it's defined as lambda, but it's the same. So when it's listening, it's going to be RGB blue, slow pulse. When it's thinking, it's going to be blue, fast pulse. When it's replying, it's going to be blue, no pulse. When it's an error, it's going to be red. When it's muted, it's going to be turn off. When it's not ready, turn off. And by default, it's going to be white, 20%.
So these would be the kind of things where in the voice assistant contest, the final category that the best voice experience. To me, this would be where you've put in a lot of effort to make sure that the design language of whatever you're doing is very clear as to what's happening.
Yeah, I still have the same error. Okay, and so that will be the end. I will show you how it looks. It's going to be, I'm not going to say like it's final because, I mean, look at the thing. It's still like a, but at least it's going to be, I will make a few things that are smart, and we'll see how it goes, more or less.
There's some questions or some chatter in the chat about Wyoming Satellites and mute. So they do have mute. The assist microphone add-on, I need to bump a version to get that in there. So this is coming. Don't worry. The mute's going to be there soon.
Okay, cool. But there is a mute here.
Yeah.
So this is the init. It's going to init for the first time. So that's like more or less I'm connecting to the Wi-Fi for the first time. That's an error. I don't know why, but okay, this is done more or less. If I turn off the WakeWord, it's going to be actually interesting. There is an error when I turn off the WakeWord. Okay. I mean, this is good because it's popping up the real errors. And then the nice thing is that if I disable it, if I disconnect it from Home Assistant, for example, click, it's going to go back to just being, like I cannot speak to that, so it's turned off, right? If I enable it, it's going to be turned on. So that's kind of like a nice way, and it's still working. I mean, I hope so. Framboise, turn on the bunny.
Sorry, I couldn't understand that.
I'm speaking on the other side of the microphone. Framboise, turn on the bunny.
Turned on the light.
Yeah. So this one will be shared with the community soon, tomorrow. I will have to find a way to share it. All right. So
thank you to everyone for sticking with us through all of this. We've, like I said, we built a lot last year, and so we had a lot to show off, and we kind of wanted to kick off with a tutorial here on different things so you could get some ideas basically for the voice assistant contest, right?
Yeah, that was the goal. The goal was really like to announce the contest, what it means, what you can win, etc. And then just to help you just get started. There is 2 platforms, Raspberry Pi, ESPHome, and you have 2 base tutorial, and I'm sure that you will do like 100 times better yourself, but at least you have 2 tutorials. You have also parts of what you can use. All of this will be shared with you. It's not technically on the blog post. We have to basically update the blog post, I think, but we worked a bit hard today for that, so I will do it tomorrow.
Doing this kind of thing gives me a huge appreciation for the YouTubers that put together these video tutorials that are comprehensive and actually look good and entertaining. Like it's really difficult to do that.
I actually want to show you something because I don't want to like lie or like miss things. Like you take the voice assistant that we created on the breadboard, and usually the next part is called a protoboard, which may look like this, which is like a bunch of small holes, and you just wire the things together. So it's just smaller, right? But it's the same component. You have the ESP board, you have the amp and the speaker, and then you have like on the other side the LED and the mic. I'm not joking, it's the same components. When you have this, you just buy a toy online. This is literally a toy. I'm not joking. It's like a replica from the movie. It came all gray, so I had to paint it. So that's the part I'm showing. That's the front end. That's the part I'm showing on the videos. It's the same component. There is the board. I like hot glue guns because I'm lazy. That's the amp. That's the speaker, the LED, and the microphone. I made like a small array of holes there for the speaker, 1 hole for the microphone. The LED is in the middle of this. $50, I think, and the big part was just the toy because it's an official replica from someone that was doing collectors. So sorry, dude, because usually these things are staying on a blister. But yeah, that's one, and it's the same component. And I will not open it because the space was pretty limited, but same, exactly the same thing. The LED is here, the mic is here. I'm using the speaker off the talkie-walkie, but inside this, there is exactly the same thing. Except, small bonus, I also have the LiPo battery that is allowing me to have it on for like, I don't know, like a day. But that's kind of the same thing, more or less.
Sweet. I got myself some proto boards. I think it's time for me to graduate from using Legos to actually using something proper.
You have nothing to show us, like not like a. Didn't you show me like the thing with the screen and everything?
Oh yeah, I took that apart.
Okay, nice.
I had this cheap little speaker attached and Legoed up to this case with a Raspberry Pi screen and a PIR sensor for motion, so it just turns off the screen when you're not there. But yeah, my stuff usually ends up looking unfinished and often being unfinished. But
yeah, so and Keith is showing the final boss of this. So breadboard, perf board, and then you do custom PCBs. But that's one day, Keith, you should do something with us with like showing how to design a custom PCB, because that looks very very complex.
And then you get into 3D printing, and then I don't know how far you go from there before. Yeah.
I'm not 100% sure that I will give my word, because it's actually pretty complex to do. But Walkie Talkie are coming by pair, so I technically have another one. So maybe if I am motivated, because it took me hours to create, that could be one of the prizes of the contest. The second one.
That would be a nice one.
Oh, it removes. That's the inside, which is. So I removed everything and just put an ESP board. So maybe I will create it for you guys. All right. Well, thank you very much for following us till the end. Very professional with the. Yes.
I think the comment got stuck. We like your comment, Keith, but
it's weird. Yeah. Okay. Sorry. The walkie-talkie is on the keyboard.
Oh, that's why. Okay. All right. Well, yeah. So there should be hopefully live now the voice assistant contest forum topic. So go ahead and post your submissions or chat about stuff there, and yeah, we'll be hopefully doing some more live streams in between. At least I'd like to do some more stuff with the Raspberry Pi to go a little bit more in depth and into the different customization options.
Cool. See you.
All right. Thanks, everyone. Have a good day.
Bye-bye.
Bye.